Hi guys, today we'll implement some filters that we discussed last week on a PPG signal that we'll be recording using a PPG sensor. So let's get started. Initially we need to record the sensor values. So I have initialized a sensor value variable with 500 samples and some initializations of other variables. And in the void loop, I have taken a while loop and given the sensor value equals analog read A7 because I have taken A7 as the input pin for the sensor. It being an analog pin, I have given analog read as the command. So let's check the readings. I'll upload the code. So here's the signal that I have recorded using a PPG sensor. Now let's apply other filters to it. So here's the moving average filter. I have taken two for loops as mentioned in the previous week's video. This is the code for it, implementing of your MF filter. I have taken sensor value as the input for the MF filter, and W is the output of the MF filter. Let's check the output of this filter. I'll uncomment this. So here's the PPG signal, the blue one, and the red one is the moving average filter output. You can notice that it is way smoother than the PPG signal. So this filter is done. Let's get to other filters. Coming to the derivative filters, here also I have taken the sensor value as input for the first order derivative filter, which is x of n minus x of n minus 1, and the 3-point central difference filter x of n minus x of n minus 2. Let's check this output too along with the moving average filter. So here's our PPG signal that I've recorded, and the red one is the MF filter output, and here you can notice the green one, the first order derivative filter, emphasizing the higher slopes in the recorded signal, and the orange one is the 3-point central difference filter. You can notice the filtering and the difference between the two derivative filters along with the MF filter here. So these two filters are also done. Now we'll apply combination of filters. So the filter here is the first order derivative filter output is given as input to the MF filter. So here's the code for it. You can see Y is the output of the first order derivative filter. I've given it as input to the MF filter code and taken P as the output. And here's the code for the 3-point central difference input to the MF filter. See, you can notice that is the output of 3-point central difference, and I have given it as input to the MF filter code, and Q is the output which we require. Let's check this code too. Now let's see all the outputs at a time. Okay, I'll upload. So here's the final output. This is the PPG signal. This is the MF filter output of this signal, and the green one is the first order derivative filter output. The orange one is the 3-point central difference filter output. These are the two derivative filters. And here the purple one, you can notice here, this is the output of the first order derivative filter given as input to the MF filter, and this grayish black one as the 3-point central difference is given as input to the MF filter. Let's give it some time to settle and get stable. So it's getting settled. So here's the output or the plots. You can notice the difference between them. Now all the filters are done. Thank you.